Hi, welcome to Knowledge Base. In this video, I'll explain how servo motor works, how it is connected to the power supply and microcontroller, and what are these PWMs which control that servo motor, and what is this dark. Okay, before going to servo motor, in my previous video I had explained about simple kinematics calculations for your to make your robotic arm autonomous. In that, I have explained some basics on how do you calculate the distance between the robotic arm center and the object placed in the work area, and what all the angles the servo has to rotate so that the robotic manipulator, that is the gripper, reaches the object. So, how do you decide? How do you tell the servo motor to rotate so and so degree? Okay, so that is what I am covering in this video. Sorry. So let me show you this servo motor. This is 10 kg cm metal gate servo motor, and this comes with horns like this, servo horns. So basically you connect this mechanical structure, that mechanical links to this servo horn, and then you connect this horn to this shaft of the servo motor. Okay, this is how these things are useful. And the servo motor has three wires. Okay, the first one, which is orange colored or light colored one. Okay, there are different standards. Different companies has its own color coding, but basically the light colored one, like orange, white, or yellow, are used for signal. The red color or dark red colored, this is little light, and there are like dark red color kind of wires in some of the motors. Middle one, okay, this is for voltage, that is plus 5 volts or 6 volts. And this dark colored one, black, brown, all these things, all these wires, the third pin is basically ground. Okay, so the connectors has a standard. Okay, so these are the standard connectors used for servo, which you can, you can use Berg strips also to connect to this wire. Okay, so this is the servo motor. Okay, let's look how it is connected to microcontroller and power. If you are using a low power, there are specifications written on the boxes like this. You will have all the spec. This servo will work from 4.8 to 6 volts. Okay, this box is doesn't belong to that metal, but just to show you the specification, I took this box. Okay, this is actually a 4.8 kg cm. The kg cm torque motor. Okay. Okay, there will be like specification, voltage specification. Some motors, some servos will work only from 4.8 to 5 volts. Okay, and this one will work from 4.8 to 6 volts, and this metal gate also, it works at 6 volts. Okay, so even this has a range from 4.8 to 6 volts. Okay, so if you are connecting a servo at 5 volts, it is very simple. You have this 5 volts connected to your microcontroller, and then the same 5 volts is connected to your servo, and ground is connected to microcontroller and servo. The signal pin, one of the IO pin of the microcontroller, is connected to signal pin. But when you have 6 volts like this metal gate, this requires 6 volts to efficiently work at its highest torque rated. Okay, so you can connect this microcontroller to the 5 volts power supply and servo to the 6 volts power supply, and you will short the ground pins, okay, of both the power supplies, okay, and then connect to microcontroller and servo. Okay, that means there should be a common ground for microcontroller and servo. So what you do is in the power supply, you will take both the ground pins and short them. That is the way, and you have to connect the IO pin to the servo similarly. Okay, so servos work according to the PWM generated. That means the signal pin, which you have connected to the microcontroller, in that pin you have to generate pulse of positive pulse of 1 millisecond and negative pulse of 19. Okay, the pulse length. Okay, the entire pulse length is 20 millisecond. That means for 1 second you are generating this pulse of 50 times. I mean, you are generating this pulse for 50 times. So the frequency of this pulse sent to the servo motor is 50 hertz. Okay, so each pulse is of 20 millisecond. That means if you are sending positive pulse of 1 millisecond, remaining negative pulse, it has to be I mean the subtraction 20 millisecond minus 1 millisecond, that is 19 millisecond. So similarly, if you are sending 2 millisecond, the negative pulse, I mean the zero pulse has to be at 18 millisecond. Okay, so the positive pulse, whatever you send, depending on the width of this pulse, servo will rotate clockwise or counterclockwise, and this determines how much it has to rotate. So the degree, I mean the angle, how much it has to rotate, is defined from this positive pulse. Okay, so when you send 1 millisecond, the servo will be at 0th position. 1.5, it is at 90 degree, that means it will be at the middle, and then 2 millisecond it will rotate to 180 degree. So this is the convention, this is the specification of the servo. But what happens, these hobby servos tend to give you some errors. That means at 1 millisecond it could be at some 30 degree, 45 degree, 50 degree, like that. So you have to check that and calibrate them. The servo what I took some years back, what I had, it used to work only from 0 to 90 degree. Okay, so for 1 millisecond it used to be at 0 degree, and 2 millisecond it will be at 90 degree. But if you increase or decrease the range, that means if you decrease this range 1 millisecond to 0.8 millisecond, it will extend its range also. Okay, those things you have to take care. But when you are building a robotic arm, 90 degree is more than enough. Okay, rotation of 90 degree is more than enough to construct your robotic arm. Okay, so there is one more thing which I have to tell you, that is torque. Torque is basically the amount of force acting at the center of this shaft. Okay, the shaft can hold a force of 10 kg cm. Okay, so this motor is 10 kg cm motor. Okay, so that means from this shaft, if you try, I mean if the weight is at 1 centimeter, okay, from this shaft, if you place 10 kg, it can handle 10 kg. Okay, so that means if you multiply these two, you will get this 10 into 1 centimeter, it is 10 kg cm. Okay, so the force acting here is always constant. That means if you go further from this shaft, let's say if you are at 5 centimeter, the amount, I mean the weight which it can lift here at this place is 2 kg. So 2 into 5 kg, you will get 10 kg cm. Like that, it is the same concept of lever. If you go away, I mean if you are at 10 centimeter from the center, it can only handle 1 kg. So this is the concept of this torque. That means if you are building a arm which is of a length of 10 centimeter, okay, the link is of 10 centimeter, the weight which it can hold at this point is 1 kg. Okay, it can lift 1 kg at this point. But the thing is, as and when you go further, okay, let me take a divider. Okay, let's assume you have connected this servo to the base of the robotic arm. Okay, when the robotic arm extends its links, the force acting at this point will increase a lot. Okay, so all these things you have to consider. Okay, you have to consider the torque of the motor, and how much the robotic arm is extending, and total force acting because of this extension. It should not increase, it should not go beyond 10 kg cm. It should be in the limit. Okay, so these are the things which you have to take care. These things you have to know in order to use the servo motor. Okay, so next we'll see how to generate this PWM, and how these delays are generated in basically I'm using PIC 18F4550, and the IDE and compiler is MPLAB-X and XE8 compiler. Okay, so this is about all the servo motor, I mean what it is. Okay, so I forgot to show you the specification. Let me show this now itself. Okay, it is focused. Okay, now if you see, the spec says operating voltage is at 4.8 to 6 volts. Okay, that means it can work from 4.8 to 6 volts. But same thing, if you see here, torque, you can see at 4 volts, it is actually it can carry up to 5 kgcm. Okay, the torque it can handle is 5 kgcm. If you apply a 6 volts, okay, so then the torque increases. So that is the range. So in case if you have 6 volts power supply, use that 6 volts power supply. Okay, so to get the higher torque. And then if you see the PWM range, it says 20 plus or minus 2 milliseconds. That means 20 milliseconds, but it has a tolerance of plus or minus 2 milliseconds. Okay, and it works at positive pulse 1 millisecond to 2 millisecond. Okay, and this says the standard direction is counterclockwise. Okay, so that means at 1 millisecond it will be it travels from 0 to 180 degree counterclockwise. So something like this. Okay, so in this example here what I shown opposite to that. Okay, anyway, that I'll show you when I'm working, you will come to know. Okay, and it is accepting 1500 to 1900. It is not seconds, it should be microseconds. Okay, so it is 1.5 milliseconds to 1.9 millisecond. Okay, so that is why my motor was working only from 0 to 90 degree. Okay, so then there is a stall torque which I have just explained, and it is the weight of this thing and size, and the plug availability, that is this uses Futuba kind of plug. Doesn't matter, you can always use a Berg strip to connect to that. And it says some special features like heavy duty plastic gears and economy servo and all those things are not much required for us, but the major thing what you have to take care is voltage and the torque which it can handle. Okay, now the power calculation. When you are using the servo is like it is actually power hungry. These servos, these metal servos will easily consume 950 milliampere to 1 amp and all. So let's say if you are building your robotic arm and you are using 5 servo motors, and if each servo motor is consuming 5 volts and 1 amp, that means the entire power supply's wattage is 5 into 5, that means 25 watts. That means you should have a power supply which can provide 5 volts, 5 amperes of current, because each servo can consume 1 amp at its peak of its torque. That means whenever there is a heavy load and which is lifting, it will consume so much. Okay, so normally what happens, that is for simplicity, but normally servo motor consumes around 800 milliamp. Okay, so this is about power supply. Okay, so next video we'll see how to generate this PWM using MPLAB and XC8, and how these delays are calculated. Okay, thank you.